Good afternoon, students. I want to talk to you a little bit about the Milestone 8 assignment because this is one that students often struggle with, and I've gotten some feedback that I'm not really sure what you're asking me to do. So I'm going to try to break it down for you and make sure that you really understand it. So what this is really about is we are now taking our point of sale application and we are now hooking it up to a cash register machine. So the drawer that takes payment along with a receipt printer and a credit card swipe payment machine. All of these pieces are now coming together with our point of sale. So we are using, in this case, the Circle register, which is a third-party piece of hardware. They've provided us some drivers to actually talk to those three devices: the cash register, cash drawer, the credit card scanner, and the receipt printer. But it's pretty primitive in its implementation. It is not nice and pretty, and we can't just plug it directly into our project and have it work. We have to write some code to talk to it to actually make it work nice with our interface. So we are creating a GUI that is going to allow that cashier to collect the payment from the user. That's going to be triggered when we hit the complete order button. If we don't already have your cancel order button hooked up, you need to do that this time too. And we're going to do processing the payment based on if it's a credit card, if it's cash, or if it's a debit card. And we're going to print the receipt for that completed sale as well. Then, of course, if you make changes to these classes, you need to update those in your UML. All right, so what we're really after in this assignment is how do we pull these pieces together? How do we work with an outside library, so a DLL that we did not author ourselves, and how do we hook that all up and make it work? So canceling the order, this was actually in an earlier milestone, so you probably already have this set up, but basically it needs to be visible at every step in the process. So as you're taking the cash payment, you still have the option of canceling the order. And if you cancel the order, you just throw away the order object, you replace it with a brand new order that has no items in it, and you just basically start over. So that would be what we do when we cancel the order. Very straightforward. Completing the order is going to launch a payment option screen that allows you to decide if you're going to pay with cash or if you're going to pay with credit or debit. So basically like two large buttons saying cash or credit or debit. That's really all you need. Plus you still need to be able to cancel and return back to the main screen. So let's talk about credit debit cards, because this is actually the easier one. If they choose credit debit, you need to talk to that card reader, which is out of that DLL, call its run card method, and that is basically telling that credit card reader to try running whatever card just got swiped. And that method is going to return one of 5 possible values: approved, declined, read error, insufficient funds, or incorrect PIN. And that's all there is to it. Just a single method you're going to call, you get back this result. You need to let the cashier know if there was a reason it was declined. So any of these possibilities, you need to say to the cashier, it was declined for this reason. So give a message through the GUI in some form that the cashier cannot miss. You want to make sure it's very obvious that payment was declined for this reason. If it was approved, you also need to let the cashier know that it was approved. And then you complete the order, you print the receipt, and you're done. So those are the things you need to do. And then if they choose the cash option, we're going to go into the cash payment processing screen. Now this is where it gets very involved, because we have a cash drawer class in that round register DLL. It gives us a drawer that allows us to keep track of the currency that's in that drawer. And if we go look at the UML diagram we have that came from that manufacturer, you'll notice that it has pennies, nickels, dimes, quarters, dollars, half dollars. Actually, this dollars is only once. Somehow they accidentally repeated it twice, so just ignore one of those. And these are coins, by the way. So that means we're working all the way from pennies to a coin version of a dollar, so a silver dollar or a Sacagawea dollar, one of those coin-based dollars. Ones is the first of the bills, so these are bills now: $1 bills, $2 bills, $5 bills, $10 bills, 20s, 50s, 100s, and then there is a total property that tells you how much money total is in the drawer, and a method for opening the drawer and a method for resetting the drawer. So the open drawer basically just spits the drawer out so you can put money in, take money out. That's really all it does. And then the reset drawer, this is basically at certain points in the day when a cashier finishes their shift at various places. Some places do this. They will actually have them remove the cash drawer, take it back to an office, and then the next cashier gets a brand new cash drawer that they put in, and those cash drawers have a certain amount of bills and coins that is a standardized amount that's going to be in there. So calling reset drawer basically tells the register that somebody has just put in a brand new drawer that has the amount that is that standardized amount. Where you would use this is when you're unit testing, for our case, because we're not going to worry about swapping drawers during the day yet. But when you're unit testing, you want to put the drawer back into a well-known state so that it has money to actually give change. The receipt printer, it just has this print line and cut tape. We'll come back to that. And the card reader has that one run card with the transaction result, and there are the transaction results. Okay. Now, the downside is that class is very simple, but notice also that these are not properties. Notice there is no get in angle brackets, no stereotype there for get or set. So these are fields. And remember, we talked in object orientation, we really don't want to use fields because anybody can get in and change those values. It's completely uncontrolled. There's no protection against mutation. We can't add any logic to that. And that's what you're dealing with right now, is that cash drawer. Anybody who has a reference to that DLL can go start tweaking those values. You want to add that extra layer of protection in there, but you also want to be able to use this for data binding. This class cannot be used for data binding because notice it does not implement the iNotify property changed, and these are not properties. So what you're going to do is you're going to write an intermediate class, a class we call a model view class, and that is going to sit between this DLL class and your GUI to provide that extra implementation. So this intermediate class, which you might call cash drawer view model or something along those lines, is going to provide properties that correspond to all those fields. And you can use those fields as the private backing variable. Instead of declaring your own private backing variable, you can just say round register cash drawer.pennies. And that would be what you would return from your getter. And when you do the setter, you would set those values. So you can go ahead and create a series of properties, one for each one of those fields that represents the money in the drawer. Now, that's not the only money you got to keep track of, because you also need to worry about, and that's just number one here, you also need to worry about the money that you're getting from the customer. And in order to do that, you need to know what the customer is handing you. So are they handing you a 20 and a 10? Then you need to know that there's 120 and a 10 and maybe 5 cents. You've got to have all that information. So you need a property that corresponds to each possible currency to keep track of the quantity of that currency the customer is giving you to serve as change. And you also need properties to determine the amount of the currency you should give back to the customer after they have paid you as change. So when you get payment, you're going to turn around and give back some change, and we're assuming that you are going to be calculating the amount of change and how that change should be given back to the customer. That's part of the challenge of this assignment. So you will need to also write the logic for making appropriate change. And my advice to you would be put that logic in a private helper method that can be invoked anytime one of these properties of the customer handing you a bill or a coin comes in. So every time they try to give you money, any kind, any denomination, you then recalculate what you should be giving back as change. And when you finalize the transaction, you need to invoke that cash drawer open, so the drawer is open so they can actually put money in and take money out. And you need to make sure the amount of currency that you got from the customer goes into that drawer's record. So in that circle register dot fields, all those fields for that particular amount. So if they gave you 2 tens, you got to add 2 tens to the drawer. And if you gave back a $1 bill and 2 pennies as change, you need to remove those from the drawer. So all of that needs to be done as part of that finalize method. And if you set this up correctly, The amount of work you need to do in the actual view is minimal because all you're going to do is bind the objects. That's really what it boils down to. If you do it well, if you do it poorly, then you're going to have to do a lot of logic in the view, which we do not like because it's very difficult to test. But this class, because this is just a regular old vanilla class, you can write tests for. Okay. Thus, your round register cash drawer is basically taking the place of your model, but your model view class is sitting between that and your custom WPF control. And the view is using the model view model architectural pattern. That's how we're setting this up. All right, so let's talk about the cash payment control. This is one possible, it's not the only way you can do it, but it's one possible way of setting this up. So here we have the denomination of the bill or the currency, and we have the amount that we've gotten from the customer. So we have a plus and minus button. So if the customer hands us 100, we would click right here to say, oh, add one $100 bill that we're getting from the customer. And as soon as we do that, we'd want to update all of these things across the bottom, the total sale, the amount due, the change owed, to say that the amount due is now probably, since they only owed $2.15, if they gave us 100, the amount due should probably be 0. You don't need to give us any more money. And the change we owe you is now $97 and 85 cents. And you should probably, over here in the give us change, we should say to get to that amount, we're going to give a 50, 2 20s, a 5, and 5 cents and a couple pennies. Oh, this should be a penny down here. So that needs a little tweaking. But that's the basic idea. You want something that is very visual, very easy for a cashier with a minimal amount of education to come in and put these amounts in, see the result back, and figure out what that should look like. The other thing you need to worry about is what happens if, for example, we put in the customer's given us a $100 bill and we simply don't have enough change to make change for that. Then you need to have some kind of way of displaying a message saying, we can't give you enough change. You need to give us a different kind of bill or a different makeup of the amount that you want to give here. So once you are happy with the amount of change that's been given and that, you can click that finalize sale button and that will open the register, print the receipt, and all those details. Now my advice to you in doing this is don't make this control first. Instead, make a sub-control. This control right here, currency control, is one row out of this. And if you make this as a dependency object, so you set up dependency properties for the amount of bills that you're getting from the customer and the amount you need to give as change, and the denomination of the bill, you can bind these three text areas or text blocks, however you implement those, and turn around and then compose this entire control by basically just dropping an instance of this control in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 times and just tweaking the bound values. And then you just have to implement these text views and this button here and this button here, or however you arrange it. But you can actually save yourself a tremendous amount of work if you use the composition pattern and make this control be composed of this control. You will save yourself a lot of effort and time if you do it this way. And this is exactly the strategy that we used with the lobster pot game. So go back and look at that exercise and work through that and just think, how can I change what I did there to deal with currency here? Finally, you need to be able to print the receipt. So print line takes a string that's going to be an individual line, then it will move the receipt printer down one line, print the next line, move down, print the next line, move down, print the next line. Cut tape tells that register to spit the receipt out and run that little knife across it so that the tape is cut so you can just pull it out of the register. That's what that does. Now, we don't actually have a real printer, so what we're going to do instead is that DLL is going to print your receipt into a text file, and that text file is in your debug folder and it's called receipts.txt. So after you've run your program and you've completed a sale, you can go look at that file and you will see your receipt. It's going to have all the items in it. sorry, receipts.txt, make sure that's not blocked by the window. It's going to show you each line. And then it's going to also do a line of hyphens across the bottom every time you cut. So you'll see the individual order receipts separated out, and you can check visually, am I printing it the way it needs to be printed? Because it should be displaying the order number, the date and time the order was finalized, a complete list of all items that were in the order, plus their price and special instructions, the subtotal for the order, the tax for the order, the total for the order, how it was paid for, and the amount of change owed, if there was change owed. So if it's a card, obviously you're not going to get any change. Okay. There's one other very, very, very important caveat you need to pay attention to. Each line in the receipt can be no longer than 40 characters. If you give print line a line that's longer than 40 characters, the extra characters are just going to get thrown away and your receipt's going to be incomplete. So make sure that as you're printing this, you're thinking about, what am I printing on the line? Do I need to do something special like abbreviate the line or span multiple lines if what I'm printing is actually going to turn out to be too long to fit within that 40 character limit? And this is the kind of restriction we see all the time in the real world. The printer physically can't fit more than 40 characters on that receipt tape, but the DLL that we're working with doesn't give us any warnings about that, doesn't cause any problems in the compilation process, so you can very happily tell it to print stuff that it won't fit, and it'll just consume it, and you'll get receipts that make your customers angry because parts of the receipt are missing. So you need to be sure that your code is accounting for that particular problem. Finally, you need to test this. And one of the best benefits of that MVVM architecture is that we can unit test our view model classes. Now be aware that we are using Net 5.0 Windows for the point of sale. That means that if you try to set the a project as a dependency of that, it's not going to work. You need to create a new XUnit project, point of sale tests, and once you do that, here I have point of sale test. If you double click on this solution file, notice when you first build it, if you build it as a .NET 5.0, which is the only one you have a template for, it's going to look like this for the target framework. You need to add a -Windows. That makes it able to work in conjunction with our point of sale project. So once you save that, then you can come to point of sale test, add the project reference, and say this is going to reference the point of sale project, and it will compile without a problem. If you leave it as a .NET 5.0, it will tell you that the two frameworks are incompatible, and the unit test can't actually use the point of sale project as a dependency. So you have to make this change. And this just walks you through that. Okay. Other thing on the unit test, be sure you call that reset method of the cache drawer every single time you start a new unit test, because otherwise you won't get that accounted for. You want that cache drawer to be in its default state when you start. So you should test that unit model, including all your logic for making change thoroughly in your unit tests. That's the best place to do it. Now the GUI side, obviously it's hard to test GUIs. With unit tests, we don't have a good set of tools for doing that, so you're going to instead add the GUI payment tests into your test document. So update that test document to deal with taking the credit card payment, taking a cash payment, stopping a payment early to go back and add additional items, and also canceling the order and starting a new one. Any changes you make to UML, you need to add that UML diagram, then you can go ahead and submit this. And like always, if it doesn't compile, you get a grade of 0, so make sure that you actually compile and everything works when you turn it in. 20% is going to be on your structure, 20% on documentation, 20% on design, 20% on functionality, and 20% on your UML in that final grade. So be sure that you do take into account all of those. And that's it. Good luck.